Let's learn about direct and indirect variation. So here we're given a table and we're asked if this represents a direct variation or an inverse variation, and then to write an equation depending on how that works. So for direct variation, it's pretty much going to be a linear function. So you're going to have some kind of y equals mx plus b, but your b, your y-intercept, is going to be 0. So that's a direct variation where y is going to be a multiple of m. There are different ways of doing that, and we're actually going to go over those as we look through this problem. But for an indirect variation, instead of multiplying a constant by x, you're going to be taking the constant and dividing by x. So that's where we start talking about rational functions, where we have our variable in the denominator. So there are a couple strategies to go through to check if something is direct variation, so depending on how you look at it. So the first is if your y divided by x is actually the same. So this is part A. So if you take 0.2, the y value, divided by the x value, that gives you 0.2. The second part, 0.4 divided by 2. The third point, 0.6 divided by 3. So all of these are 0.2. So because of that, these are the same. So I already know this is going to be a direct variation. That's the relationship that occurs here. So another way of looking at this, again, if the numbers are nice, is if you're multiplying x by the same number to get y. So I can see that all of these I'm actually multiplying by 0.2 every time. So if I divide them, I get 0.2. The x times 0.2 is always going to give me the y value. The third strategy is by looking specifically at the slope, or the change in y values divided by the change in the x values. So the x values in this case are increasing by 1. The y values are increasing by 0.2. So again, because you're increasing by 0.2, the y's and the x's are increasing by 1, you get 0.2. So it doesn't matter where you do this. 0.2, 0.2, 0.2. There's some kind of constant rate of change. Hence, direct variation. So the way we write this equation is going to be y equals, and 0.2 is our rate of change. So 0.2 times x. That would be our equation for this one. So for our second problem, it's similar. We have a table with x and y values. So we're going to go through the same strategies. So in this case, when I look at going from x to y, so 4 times something is going to give me 5. That might not be the best strategy in this case. So this strategy right here might not work very well depending on how the numbers fall. So we could do the y divided by x, right? That first part. So 5 over 4. The second line is 10 over 8, which simplifies to 5 over 4 when you divide by 2. The next one is 15 over 10, which simplifies to 3 halves. So I already know this is not going to be direct, because these are not going to be the same values. And then 20 divided by 22 is 10/11. So it's definitely not going to be direct variation. We'll go through the third method also, just to see. The x values are changing by 4. The y values are changing by 5. That's where the 5/4 comes from. The next one, it's changing by 2. That's changing by 5. That's not consistent, because if the y's are increasing by 5, then the x's should also be increasing by the same value. So there's no constant rate of change. So now we have to focus our attention on whether this is going to be an indirect relationship. So if y is going to equal to some number divided by x, we can rearrange this. And pretty much if we multiply by x, it means when you multiply x times y, it has to give you the same number each time. So if we look at this table again, and you organize it by rows, the first row, 4 times 5, gives us 20. The second row, 8 times 10 is going to give us 80. 10 times 15 is 150, so this is not going to be indirect either. So the indirect relationship is really multiplying your x times y values, and then your direct relationship is actually dividing the y and x values. You just have to make sure you put them in the right order when checking. But that's how you check for direct and inverse variation and how you would write the equations if you had it.